Good day, viewers. In our class today, we shall be looking at the topic mensuration, a very broad topic. All right, but we're going to be treating it under 4 or 5 presentations. First of all, we're going to be looking at the meaning. When you hear the word mensuration, what comes to your mind? What does it mean? All right. Then we'll look at some basic knowledge that we need to recall, okay, for a better understanding of this topic as we go deep. All right. They'll look at the length of arcs, area of sectors, perimeter of a sector. Okay. We also look at volumes of solids, solids such as cube, cuboid, cone, cylinder, and lots of them. Then we'll look at frustum. All right. We also look at what? Frustum. First of all, what is mensuration? When you hear the word mensuration, what comes to your mind? It has to do with all process that involves measuring or calculating of length, areas, and volumes of geometrical shapes. And these geometrical shapes can be in 2 categories: plane shapes and what? Solids. Plane shapes and solids. Now, to follow up well in this lesson, there are some basic formulas that it's important for us to recall. It will really help us as we go deep into the into the lesson. Right, first we start with plane shapes. For the sake of time, we will not be doing all the writing, most of the writing in this presentation. We'll just try to recall verbally. Okay, let's start with a rectangle. You know, a rectangle has opposite sides to be equal, right? So what do you know about area of a rectangle? Area of a rectangle is given by what? Length times breadth. And the perimeter is given by 2 bracket length plus breadth. This is for a rectangle. For a square, all the sides are equal. If you have a square giving sides L, the area is what? L square. And the perimeter is given to be what? 4L. All right. You have a parallelogram. I will need to draw this shape. Parallelogram looks like this. All right. You have here to be A, here to be what? B. Remember, parallelogram, opposite sides are equal and what? Parallel. Opposite angles are also what? Equal. Now you have the height of a parallelogram this way. This height is perpendicular to the base. You have something like this, angle 90 here. Suppose you have an angle here. What will be the area of this parallelogram? Area can be given by what? Base times height. All right, the base times height. This is the height. Okay, or if you consider this right angle triangle, okay, you apply Pythagoras rule. No, you apply sine rule. Okay, you have h equals a sine theta. All right. From the basic SOHCAHTOA that we know. All right, this acronym: S, sine of the angle; O, opposite hypotenuse. So the opposite sides of this is h, hypotenuse is a. So sine of the angle theta is given by the opposite over what? Hypotenuse. That is h over a is sine theta. All right. So what is your h? Cross multiply. You have your h, a sine theta. This is your h. All right. So the base area now can be written as what? Also a b sine theta. All right, where your h is a sine theta, you substitute. You have this to be given by another formula for what? Parallel area of the what? Parallelogram. All right. We also have for triangle. All right, for a triangle, we need to write that the triangle, the area of a triangle is half times base times height. All right, half times base times height. But if you are given 2 sides of a triangle and an angle, the area is what? Okay, area of a triangle, half base times height. But given 2 sides of a triangle with an angle, the area can be given by what? Half AB sine C. All right, or you have half AC sine B. You also have half BC sine A. That is given 2 sides and an angle. You apply this for the what? To get the what? Area. All right. Lest I forget, the perimeter of a parallelogram, just like that of a rectangle, is 2 bracket A plus B. Perimeter of a what? Parallelogram. These are basic formulas that we should know. We just need to recall them to help us as we go deep into this topic. All right. Okay. We can also be given a triangle of 3 sides, no angle. Right. In that case, how do you obtain the area of the triangle? We apply what we call the Heron's formula. All right. And this is given by what? Area by Heron's formula is given by root of S into S minus A, S minus B, S minus C, and your S is given by the sum of the 3 sides by divided by 2. All right. Use this formula to obtain the area of a triangle given of 3 sides. All right. And your S is given by what? The sum of the 3 sides divided by 2. Okay. We also need to recall a very important theorem on triangles, which says that triangles on the same base with the same triangles on the same base within the same parallel lines are equal. The areas of triangles on the same base within the same parallel lines are equal. That theorem is very important. We're going to be needing it also. All right. Okay. In summary, to get a better understanding of mensuration, it's very important that we recall these basics that we just wrote on the board. All right. This formulas presented involves plane shapes. So now next class, we're going to look at that of solids. All right. And then we go into problem solving. So please ensure you follow our lessons gradually so that the problem of mensuration will never be an issue for you anymore, right? As far as mathematics is what concerned. So that is all for the first presentation. So please try to recall this formula. It really help us a lot as we go further. Okay. Now, moving further, we also need to recall the volumes of solids. The volumes of what? Solids, such as cube, cuboid, cylinder, cone, pyramid. Okay. Let's start with cuboid. You know what the cuboid is, right? The cuboid has how many faces? 6 square faces. All right, 6 square faces. So the surface area of a cuboid is given by what? Each of the face is a square, right? So you have for the area, each of the area of each face should be what? L square, right? So the surface area of a cuboid so the surface area will be given by what? L, that is the sum of the areas of the 6 faces. That will give us 6 L square. All right. And then the volume of a cube of a cube is what? L cube. That is for a cube. All right. For a cuboid, what is the volume of a cuboid? The volume is what? Length times base times height. All right. Now a cuboid also has 6 faces, but each of the face is a what? Rectangle. Okay. So for each face, area of each face of a cuboid is what? Length times breadth. Okay. Length times breadth, length times height, height times, right? For each of it. Okay. And remember, opposite faces are what? Equal. So you're going to have in what? Length times breadth plus length times breadth. All right. If we continue this way, we end up with what? 2 into length times breadth. All right. Plus base breadth times height plus length times height. Right. This will end up with the surface area of the cuboid. That is the surface area. All right. And then the volume of a cuboid is length times base times height. This is for cube and what? Cuboid. Okay. Now for a cylinder, we know what a cylinder looks like, right? We know what a cylinder looks like. A tin of milk, for example, is a cylindrical shape. Okay. Now for a cylinder, we're just trying to recall. For cylinder, what is the volume of a cylinder? 2 pi r square h. That is the volume of a what? Cylinder. Okay. This curved surface area. Remember, a cylinder is curved. Curved surface area of a cylinder is given by what? 2 pi r h. Let me. All right. So what we also have total surface area of a cuboid. So given by what? The curved surface area 2 pi r h plus, remember, a cylinder has two circular base. All right. So for each circular base is pi r square. For both, it will be what now? 2 pi r square. So when you factorize 2 pi r from here, you have 2 pi r, you have h plus r. This is the total surface area of a cylinder. We're just trying to recall these formulas. Okay. Then for a cone, remember, a cone looks like this, something like this, right? This is the center of the circular base. This is radius, this is height, this is the slant height. So for a cone, the volume of a cone is what? 1/3 of the volume of a what? Cylinder. Okay, 1/3 pi r square h. Okay, the curved surface area, let me write it as CSA, is given by pi RL. Pi times radius times the slant height. Okay, L is the slant height. Then the total surface area, TSA, is the curved surface area pi RL plus pi r square. All right. So by factorization, you're going to have pi r is common, L plus r. That is the total surface area of a cone. Okay. Then for a pyramid, remember, the name of a pyramid depends on the shape on its base, right? But generally, the volume of a pyramid is given by what? 1/3 times base area times what? Height. All right. So the height is always constant, but this base area changes. Okay. So if you have a square base, you know the area of a square. If you have a rectangular base, area of a rectangle. All right. So if it's a rectangular based pyramid, you have 1/3 times what? Base times height, length times breadth times height. Okay. If it's a square, L square times height. Okay. That is that. So with this, I think we've come to an end of the first presentation. So please, it is important that we recall all these formulas, all right, so that when we get into problem solving, applying the formulas will not be an issue anymore. All right. So I wish you all the best. Please stay tuned for the next class. Bye for now.